Okay. Good morning, guys. First, this next Monday we have the exam meter, and you will be able to download the meter question on the canvas. Yeah. And also the professor saw he will hold a room meeting. And if you have any question about the meter problem, you can go to his room, and he will help you to. He will clarify the question. Yeah. Okay. Any questions so far? Today I will go through the pretty exam. Okay. Okay. If you don't have any question, I will start to go to the pretty exam. Okay. Okay. So the first one is about the method moment and the MLE. Okay. Okay. Okay, so we have the density. Look at this. From this, you can know that this is a beta distribution, and with the parameter 2 and theta. So if you know this beta, then we can find the mean and variance. So that would be very helpful. Okay. And for question A, we want to find the method moment estimator. Okay. So for this, we have to find like the average of x. And this is equal to like you can see theta 1 minus theta. Or I can say it's like this, x 1 minus x, theta minus 1 dx. And it has to divide it by the beta function alpha 2 and theta. And this is density, so I have to multiply another x. Okay. Here the beta 2 over beta alpha and beta is equal to this is the definition. Okay. So you can say like if it's a beta 2 theta, then it will be 2 theta 2 plus theta, and it should be 2 factorial. So this should be 1. This should be 1, and and the ratio of these two will be theta plus 1. Okay. So we can get same density. Okay. And this is equal to like the So what I want to do is like this: the beta 2 theta, and here's x squared 1 minus x theta minus 1 dx. And you can see this one if you divide it by the beta 3 theta, then you can become a density. So beta 3 theta. So then this whole term will be the density of the beta distribution with the parameter 3 at theta. So the integral of this will be 1. So we only have to calculate this ratio. Yeah, okay. Yeah, that's a trick. So basically with this trick, you can calculate any moment of the beta distribution. Yeah. Yeah, so, but actually, if you know it's beta, then you can know that the average, the beta will be, here's the formula. Where's the formula? Okay. It will be 2 theta over 2. Okay. Theta plus 2. So it should be alpha beta plus 1. I guess. We'll see. So this is beta 3 plus theta, beta 2 theta. Okay. And this is equal to, so we plug in a definition, that will be 3 theta 3 plus theta 2 theta 2 plus theta. Okay. So we can cancel this 2, and we will have the, and this one will be 2, and this one will be 1. So it's 2 over the ratio of these 2, and the ratio of these 2 will be 2 plus theta. Okay. Okay. So this is the average of the beta distribution. And then we can do some rearrangement, and we will be able to find the maximum moment. So we can say we want to use S bar equal to 2 plus theta head maximum moment. Then after some rearrangement, it will be 2S bar plus S bar theta head Mn 2. So you'll be 2 minus 2S bar divided by S bar. So it should be 2S bar minus 2. Okay. Okay. So this is a maximum moment estimator. Okay. And yes. And the last one is want to calculate bias of a maximum moment. Okay. So for the bias, we want to here we assume the sample size is equal to 1. So next is pointer. If it is not 1, I don't know how to do that. Yeah. Okay. So the n equal to 1. So then this one can be written as a 2x minus 2. Then we find the average of this equal to average of this minus 2. So the key is want to find this. So this is a more, so some the way we find this can be similar as what we did in here. So this one is equal to like we use the same thing. This is equal to 2 and theta, and the integral is x inverse and x 1 minus x theta minus 1 dx. Yes. Okay, yes, that's right. From 0 to 1, okay. Okay, so this is equal to 0 to 1. So it should be 1 minus x. Okay, so we can divide it by the 1 theta. And this is 1 theta. Okay. Yes. Yes, n equal to 1, so s bar equal to cx. Yeah. And yes, because if this is s bar, then we don't know the distribution of s bar. So in that case, this question will be very, very hard. Yeah. Okay. So then this one will be 1. So then we only have to deal with this ratio. Okay. So this is equal to 1 theta 1 plus theta, okay, divided by 2 theta, 2 plus theta. Okay, so this is 1. This 2 can be cancelled, and this is also 1. So it should be equal to 2 plus theta, 1 plus theta. So it can be, this is 1 plus theta. Okay. Okay. So the average of this is 1 plus theta. So the average of this is equal to 2 1 plus theta minus 2. Okay. So it should be 2 theta. Okay. And then we find a bias. So the bias will be 2 theta minus theta, which is theta. Okay, this bias. Okay, any questions so far? So this is just a standard approach. Okay, and then we want to find the feature information contain S1 to Sn. Okay. Question C. So let's define like the about L theta is an IQ function. So it should be the product of I from 1 to n. And okay. And this is equal to theta plus 1 power n. Is theta plus 1? Yes. And product of Si and product of 1 minus Si to the power theta minus 1. So this is negative function. And the log negative function is Okay. Okay. So first, the facial information matrix, this one is equal to the average of the second gradient. This 10 negative. So I want to calculate this first. Okay, so I take log, so it's n theta n plus n log theta plus 1 plus log product xi plus theta minus 1 summation of log xi, 1 minus xi. Okay. To use what we need to show beta is exponential family. You mean use this? Yes, the beta, the exponential family is a sufficient condition for that. Yeah. 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 So yeah. Thank you, Albert. So this is because yes, like the yes. So here is the beta. This is exponential. Yes, like the swapping the differential and integrals. Oh. Yes. Yes, because when we do this, we want to change the integration and the differentiation. So and exponential family can measure this one is whole. So this is sufficient condition. Yeah. Thank you, guys. Yeah. Okay. And then we find with derivative, we find this, okay, which is equal to this plus theta plus 1 and plus this. Okay. Okay. So we do it again. It's negative minus the theta plus 1 square n, and this one is 0. Okay. So the facial information matrix, when we have sample n sample, it will be this. Okay. So this one is strictly positive. So if we can find a solution, then it should be the unique solution. Yeah. Okay. We can say this one is strictly negative. Okay. Okay. So next we want to find MLE. So basically we want to solve this equation. Okay. So we have to solve. Yeah. Okay. And we can see like the okay. Let's solve this. Okay. So that's divided by n. So it can be equal to this. So for the, okay, next say this one is equal to define as a test statistic Tn. Okay. So then we have to, then we have this. And know that the Tn is should be a negative number because of 1 minus Si is between 0 and 1, so this is negative. And we multiply theta and theta plus 1. Okay. So we can have the theta plus 1 plus theta, theta, and theta plus 1. Okay. So this is the second order polynomial. So we should be able to find a solution by using the formula. Okay. So, but we have to change this to a nicer form. So this is equal to, this is theta squared plus theta. So it should be theta squared plus theta. This is 2 theta, okay, plus 2 theta plus Tn. Okay. So I divided by Tn in both sides. Yeah, so it's Tn here. 2 theta plus 1. Yeah, that's it. Okay. So this is equal to 2 theta plus 1 theta. Okay. And the solution of theta hat should be equal to, the solution for this equation should be equal to 2 and negative of this quantity. So it's negative plus and minus square root of the square of this, the second term. And we minus 4 times this. Okay. So the first one we have to do that. This one is negative number. Okay, it's negative. So this this term will be bigger than this term. So we have one solution which is positive and another one which is negative. And from the question, we know that the theta should be positive. Okay. So so the only solution, so we can have the theta hat equal to this. So we can say because the theta should be positive, so the only solution is this. Okay. Okay. Any questions so far? Okay. And also we know that because what's that? The second gradient of the localized function is negative. So next is also implying the theta hat is the unique solution. In the leader to infinity. Okay. Okay, so that is the first question. So basically, you have to learn how to do a math moment and MLE, and it's very important to you to show that the MLE is unique when you want to find a MLE. Okay, the second question. So we have 45 minutes. As is now. Okay, this is a compare sufficient question. Okay. Ooh. Okay. So we have a density, look at this. And we have two parameters, tau and beta. For A, if beta is known, then we want to show this is compare sufficient. Okay. For beta is known, that's a very good news. Because in that case, the density is an exponential family. Okay. So you can see like the theta. And this is equal to like the product of the tau, beta tau, xi, tau minus 1. And we can have an indicator function of the beta value should be smaller than beta. Okay. And we can do some rearrangement. This is tau n, beta n tau. And this is an exponential of the log tau minus 1 and summation of log xi. Okay. Okay. And we have an indicator function. So you can see that if the beta is long, then okay, do we need to know that smaller one larger than zero? Here we ignore this one because this way is independent. It's not depend on the parameter. So it's not depend on the theta. So we only care about when your domain is depend on the parameter. Yeah. Okay. We depend on the unknown parameter. Yeah. So like when A, we say beta is known, so we can get rid of this term. Then you can see this is exponential family. So you get, yeah. Yeah, I didn't write this because it can simplify, yeah. But if yeah, simplify the equation, yeah. Okay. So you can write that all the data should be positive. So we only focus on the positive value, okay, like this. So for A, beta is known, and that's a great question, yeah. For A, beta is known. So in this case, this is a exponential family. So from the theory, this is compute sufficient. Okay, and this one is equal to log product si, and the log is one-to-one function. So product si are also compute sufficient. Okay. So in this case, we are very lucky. This is an exponential family, but the second one is not. So we have to calculate. Okay. So when the tau is known, we want to show that the largest order statistic. So it's a Sn is a compute sufficient. Okay. So the sufficient part is easy because you can look at this, and by the factorial theory, but we have to make sure it is a compute sufficient. So for the completeness, it should be one-to-one function. So if this is complete, and okay. Oh no, for the sufficient part, a function of sufficient statistic may not be a sufficient statistic. So only one-to-one function can be sufficient. Yeah. Nature 3. Okay, let me check. This one. Nature 4. Okay. Nature 4. So it's complete, and the function of complete statistic. Okay, the function of complete statistic is also complete. Yes. So, but the function of a sufficient statistics may not be sufficient unless it's a one-to-one function. Okay. Yes. It's not here. So, so log is a function, so you can measure the you can say like this imply is complete, and because the log is 1 to 1, also make sure the product SI is sufficient. Okay. In this case, very obvious because it's tau minus 1, so it should be full rank. Yeah.
I'm actually not completely sure I understand the concept of full rank. What could you go over what full rank means?
Okay. So the definition of full rank is like the span of the parameter tau should contain an offset. So we have to say like this one should be like the tau minus 1, and the domain in here is this. So the parametric space is like this. You have to show this one is open, contain open set. Okay. So like so this is one dimension, so you should always contain open set. So if this one is like this, for example, so if this is an exponential, like the tau function of x plus like tau 2 tau square, another function of x. Okay. Then this space, the parameter space will be like this. A parameter space will be like this, tau square, and the tau greater than 0. So in this case, it's a curve on the two-dimensional space. So in that case, it's not a full rank. It's not clear. Yeah. So
I see. Yeah, thank you.
yeah. Okay. Do we have math on argument about it? Okay. It's more informal terms. In more informal terms, parameter set has four dimension. So the restriction and reduce. Yes. So here we don't have any restriction. So it's still full rank. Yeah. Yeah, that's a very good question. Okay. 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 So okay, so let's go on. So for B, the beta is unknown. Okay. So first, the sufficient part is easy because you can use the factorized theory. Sufficient. So the only thing we have to show that the Sn is complete. So my way to do that is I want to find the distribution of Sn first. So I want to let y equal to Sn. So let's find the density of y. Okay. The density of y should be n, the CDF y x1 have the density x1. So we only have to find the city of y. First, find the distribution of y. Okay. Equal to y. And I want to plug in the density of x. So the density of x is like this. So it's tau beta tau x tau minus 1 dx. That's true. Okay. Also, you will have an indicator function. Okay. So this should be tau beta tau x tau dx. Also, that should be this 0 to 1. Okay. So it should be beta tau y to power tau. So we plug in this, then we can find the density of y is equal to n y tau beta tau to power n minus 1. And the density of x is tau beta tau y tau minus 1. Okay. So we will have like the n tau beta n tau y to the n tau minus 1. Yes, n tau minus 1 tau beta tau. Okay. And then indicate the function. Okay. Okay, so we have this. Okay, we have density. And that's for we want to check the completeness. So we want to say for any function g, we want to check the g of y equal to d 0 for every beta, then imply that the g is equal to 0. Okay. So then we have to calculate this. Okay. So give so it should be like the 0 to beta. Needle to beta n tau beta n tau y n tau minus 1 and we have to g of y dy. Okay, so this should be 0 for every beta. And because these are the parameters, so we can get rid of this. So we can have like the, so we may have the, this will imply that the 0 to beta gy yn tau minus 1 dy equal to 0. So this is, we can define this function as the L of beta. Okay. For beta. And then we can find the derivative of this. This should be also be 0. And the derivative of this is by fundamental theory of calculus. So it should be the G of beta n tau minus 1. Okay. Then this equal to 0 will imply the G beta should be 0. Okay. So imply the G beta. Okay, so the whole function is 0. Then so the Sn is complete. It's a yeah. Okay. Yeah, so you have to find the distribution first and check the completeness. Completeness, yeah. Can we put less Lagunino if Lagunino so if this one is positive, so the whole thing equal to 0 if only if the G is 0. Okay. But the G may be negative. So if G at some part is negative and some part is positive, the whole integral will also be 0. Yeah. Yeah. So okay, you're welcome. Okay. Okay. The next one is show is a minimal sufficient. See, I only have 25 minutes. Okay, I have to hurry up. Question C, minimal sufficient. So in this case, we have to apply a theory. So the theory says if we have to check. So we have the, let's say we have the Sx, Sy, and Yn. How about say this? Okay. And we want to show that the ratio of the distribution of y and x, the ratio of density of y and x is independent of the parameter if only if these two studies are the same. So let's find the ratio of density first. So they can be like the, so basically we can cancel almost everything. So okay, the ratio of these two. So we only have this term. Okay. So we will have the product of xi tau minus 1 product this y product of si tau minus 1 and indicate the function. Okay. So this term is s. This is so this is sy and this is sx. So basically this is just a function of sy, the function of these two variable, and so this is very obvious that this pattern. if only if is this the ratio of the joint PDF? Yes, just a PDF, the ratio of PDF. Okay. So if we give any two different data, we find the ratio of the density, and if the ratio of the density is independent of the beta and tau, if only if this is these two are the same. Okay. So you can see this part is easy, it's obvious. So if these two are the same, then it's easy. And this part, you can say if these two are not the same, then it should depend on beta. And if these two are not the same, then it depend on tau. So in that case, it's if only if, okay. And then we can say, so they are minimal sufficient. Okay. See the ratio of joint PD or ratio. Yeah, it's a ratio of the PDF or N data. So it's like the joint PDF. Yeah. Yeah. So it's a PDF of N data. Okay. Any more question? Okay. I have 20 minutes. So okay, this question is fine. Okay. Question 3. Here we want to find UAV of the G of theta. Okay, so it's not theta. And we want to calculate the mean square of the UAV. Okay. So first, in this question, we all so lucky. This is a exponential family. Okay. So okay. Okay. So they can say let's find density. Okay. This should be like the theta to upon n and exponential of log 1 minus theta summation si minus 1. Okay. So you can say this also full rank. Okay. So it's the full rank. It's the full rank. Okay. So this one, you can say like the mean, simple mean is the compute sufficient. So then if we can find some function of this statistic is equal to this, then that should be UAV. So first, let's find this. Also, you can see that this one is a exponential, a geometry distribution. Okay. The average of this geometric distribution is equal to theta over 1. Okay. Yeah, okay, x is geometry distribution with parameters theta. Okay. So yeah, so S bar is usually for what? So I say sometimes we may ask you to find U and V for a function of theta. So make sure you know the target before you find an UAV. Yeah. So if in this case you want to find theta, the UAV for theta, that will be very hard. But one for theta is easy. Yeah. So make sure you know that your target. Okay. And we want to find the mean square error. Okay. So the mean square error S bar is just the variance of S bar because it's unbiased. So it should be 1 over n of variance of x. Okay. What is the variance of x when it is geometric distribution? Okay, so it should be this. Theta n. Okay. Okay, so the mean square error is good. Okay. So if you can identify the distribution will be very helpful. Yeah. And then okay, conjugate pair. If we get a pair, it's a beta distribution with alpha beta alone. Then we want to show that this power is a conjugate pair. Okay. So that means we want to show that the posterior also follow the beta distribution. So we know the theta is follow the beta alpha. So we want to find the posterior. And this is proportion to the density of x, condition theta, multiplies the pi of theta. We just use pi as pi. So we can calculate this. This is equal to, what's that? The product of alpha 1 to n. Or is this alpha 1 to n? So with theta 1 minus theta xi minus 1. And also the pi of this, the beta. We only had to calculate the thing depend on theta. So theta minus 1. Okay. So this is also proportional to this. Okay. So this is from the prior, and this is from the data. Then you can calculate this. It will be like the theta to the minus 1 minus theta, then the summation of xi plus beta minus n minus 1. Yes. Then you can say, then you can, from this, we can figure out it should be found of beta distribution with parameter alpha plus n and summation of si plus beta minus n. Yeah. Yeah, I think this is right. Okay. So that means it's a conjugate prime. Okay. So the beta distribution is a conjugate prime. Okay. Is anyone talking? Okay. So the next step, we want to find the best estimator for this one. Okay. So the best estimator is the like the so we want to find the average of this condition on our sample. So this is the average of the posterior distribution. Okay. So this is a beta distribution. So you want to find the inverse model of the beta distribution. And this is same as what we did in the question 1. So do I have the answer? Where? Okay. So the same thing we can get this. Okay, let's copy this. So this equal to this. Okay. So the next question is about the linear model. Okay. Okay, so we have this. We have the so we have the metric, and we have to find this square estimator in terms of y. Also, this is some calculation. So the least square estimator is S bar transpose S inverse S transpose S inverse X transpose Y. So we have to find this. Okay. So first S bar transpose S transpose X is equal to this. So okay. Then we can find the inverse. of a finding a inverse of 2 by 2 value is easy. Just using the is equal to the determinant of x transpose x, and we have to change the order 2 and 3, and here is plus. Yes. So let's write that formula. So A is equal to A, B, C, D. And the A inverse will be the determinant of x. Oh, inverse. Okay. And you change D and A and put a negative on C and B. Okay. And you figure out what is this. Yeah, then just some calculation, you can figure out this is equal to this. So that's weird. Why the beta hash is x transpose x inverse is this. X transpose y is okay. I don't have y. We don't have y here, so it should be like this. Two. Okay, so this is this square method. And for B, what is B? We want to find the sum of square error. Okay. The sum of square error is equal to like this. I minus projection vector of x. Y transpose y. The projection vector of x is equal to x transpose x inverse x transpose. So this part is s transpose x. So we can figure out what is the projection vector. So the px is equal to this. Okay. 1, 0, 0, 0, 0, and 1 over 2, 1 over 2, negative 1 over 2. So the SSR is the y transpose the identity metric matter this, so it should be 0, 0, 0, y, and 1 over 2, 1 over 2, 1 over 2, 1 over 2. Okay. Yes. The next question. The next one is we want to find show that the UAVE this is UAV if only for B equal to D. Okay. So here we have the vector V. So we want to apply a theory. We want to show that so beta this is UAVE if only if the PXYV is symmetric. So we only have to show what's this. Okay. So we know Px is equal to 1, 0, 0. So we put out various symmetry. So it should be A, B, D, C. A, B, D, C, C. Okay. So you can guess now the matrix will be this A and these two are little. And this is B 1 over 2, B minus C, 1 over 2, C minus D, 1 over 2, D minus C, and the next one will be 1 over 2, C minus D. Yeah. No, this B minus C. B minus C and C minus D and B minus C. No, this C minus D. Okay, see. Oh no, B, C minus B. Okay. So if it's a symmetry, we need these two terms are the same. So C minus D should be equal to C minus B. And this is if only if D equal to B. Okay. So this is just a lot of calculation. Any questions so far? So for the midterm or anything?
I have a couple questions about
Sure.
the midterm. So you said we'll just like download it from Canvas. What is like can you like, what's the like, I don't know, is it just like we'll download it from Canvas and then like upload photos of our written work, or?
Let me show you. Let's see. You can find you go to the same way as where you download your assignment. So we will put a one like the button in here. Then you will be able to download a PDF from here, and you have to submit your meter in here. Yeah, just like how you submit your homework.
Okay.
Yeah.
So is it like we'll be able to download it at 7 and then at 8:30 it closes?
Yes.
Okay. And then I have another question, which is like, it seems like a lot of this practice midterm relied on like being able to identify certain distributions. So I was wondering if you had any like suggestions on like how to do that quickly.
Okay. So like if you don't know like because it's you can use computer. So if you don't know like the geometric distribution, you can just Google it. Then you can find its values as mean. I think it's fine. As long as you say it's a geometric distribution, then you can say because it's geometry, then the mean should be 1 over CP, and the variance should be like this. Yeah. Okay. Yeah. Did I answer your question?
Yeah, I mean, I guess I meant like more like the other direction, like, so like the first one was a beta distribution, but you had to realize that like the relationship between the gamma functions. So I'm just wondering like when you like look at the PDF, like, do you have tips on like how to identify the distribution from looking at the PDF, other than just like looking down a list of PDFs?
Okay, that is another question. Okay, let me see. I think, do we have a distribution table in the textbook?
Maybe.
If you can Do we have distribution table?
Yeah, it's on page 621.
Yeah, so basically all the question in the meter will not be the very weird distribution. If it's a very weird distribution, we will give you a name. Yeah. So then the beta, gamma, chi-square, this kind of distribution you have to know what is look like. Yeah. And the binomial or the negative binomial. Yeah. And the basic distribution. Yeah. So if you can know this distribution, I think will be fine. Yeah.
Okay, thanks.
Yeah. Or you can go to Professor South in his room. He will hold a room meeting during the exam. Yeah. And if you can ask him question about clarifying the exam problem.
Okay, I have a question.
Okay.
Will the lecture 13 and 14 will be part of midterm?
Can you say again? Sorry.
Will lectures 13 and 14 will be part of midterm?
You mean the content of the content of a midterm? So it's up to lecture 12. Lecture 1 to lecture 12.
Oh, okay.
Yeah, lecture 1.
Okay, got it. Thank you.
Anything I can help? So this is out of time. So if you don't have question, you feel free to go.
So the midterm is completely open notes and like we can look things up on the internet?
Yes.
Okay.
Yeah. Also can calculate algebra, geometry, metric algebra by computer. Like the pretty easy. The next question. You can just input a metric into like the mathematical or something, then they will help you to calculate it.
Yeah, that would help for that last problem with all the calculations.
Yeah, that was very helpful.
Okay, I have one more question actually, and maybe this is asking too much, so it's fine if you can't answer it. But how like what's the length of exam like in terms of like the practice exam? Like, should we expect the exam to be about the same number of problems or a little bit shorter or what?
I think will be similar, just 4 questions. Yeah.
Okay.
Yeah. And yes. I think if you can know how to do this 4 type question, it will be fine for you in midterm. Yes.
Okay, thanks.
And you can see that the most of question is a series of questions. So like question 1 will have a lot of small question. And sometimes you have to use the result of the first one to solve the second one. Yeah. So you have to be very careful for the first one. You should be right in the first one. Otherwise, all the questions will be wrong. Okay. Yes. So anything more I can help? I can join 250. You're welcome.